Hello, let's talk about volumes of revolution around the x-axis. So if we want to find the volume of a solid created by revolving the area under the curve of y equals x squared from x equals 0 to x equals 4 about the x-axis. And today we're only revolving about the x-axis. All right, so first thing we do, we draw a picture. So, should know what x squared looks like from 0 to 4. So we'll only need this portion of the graph. So x squared, this is 4, it'll look something like that. Close enough. Second step, revolve about the x-axis. If we do that, if you think of kind of first just reflecting it over the x-axis, we'll get something like that. And our shape, if you think about like the vase from the video from yesterday, our shape will end up like some version of a cylinder. It'll look something like that, or something, prettier than that, either way. And we'll have our radius there. Our third step will be to cut our sample disk and draw the radius. And so remember really what we're doing to find the volume of this solid that I have so beautifully drawn for you is we're thinking of slicing it into pieces and finding the volume of each one and adding them up. So let's make a slice right here. Here's our disk. Our radius will be right there. And if we think of our disk, we draw one edge. I kind of think of it like a coin typically. You can kind of score it right here. There's a disc. It also looks like, I don't know, maybe a wood chip. Could be a slice of an eggplant, kind of whatever you want it to be. So there's one of them. So now what we'll do is volume of a cylinder, not that this is a cylinder, this is kind of a weird cylinder, is pi r squared h. And we're going to take the integral of the volume because we want to find basically all the volumes of all the disks. So the integral of pi r squared h. Now pi will always just be pi. When we think of our radius is actually just going to be this distance here, and since it's vertical, it's just y. So r equals y, but what is y? Well, it's x squared. And the height, this is kind of weird because you think of turning it, if we think of our disk like more like this, we were stacking them all up vertically. The height right here is going up and down, over here is going to the side. So it's actually the distance along the x-axis, or the change in x, which is dx. It's again just the thickness of our disk. From here, we can rewrite and solve. So our integral goes from 0 to 4, because we're told. Pi, and now r is actually x squared, so we have pi times x squared squared times h, which is dx. we can solve this. 0 to 4 pi x squared squared is x to the 4th dx. So we end up with pi times x to the 5th over 5 from 0 to 4, which is pi times 4 to the 5th, which is 1024 over 5, minus 0 to the 5th, which is, nothing, over 5. So we end up with a volume of 1024 pi over 5. All right, let's do another. Let's find the volume of the solid formed by revolving y equals x squared plus 4 about the x-axis from x equals -1 to x equals 2. First, we'll draw our picture. A rough estimate is fine. We just kind of need to be able to see what the radius is, what dx is, etc. So we're going from -1 to 2. So there's -1, there's 2, x squared plus 4. Let's say that's 4. So it's going to maybe look like that. I'm going to rewrite that. I don't like it. Let's try again. It'll maybe look like that. We'll go with that. Okay. Then we revolve about the x-axis because that's what we're told. And if we do that, we'll get something like that. And if we draw it, again, it's some weird version of a cylinder. So it'll look like that. This one almost does look like a vase. Let's fix that a little bit. So now our third step is our sample disk and our radius. Make a sample disk maybe in the middle here. Our radius will be right there. And if we do the edge of our disk, it's a particularly bad picture, you guys. I apologize, but never claimed to be good at drawing. So there's our disk. So we're going to integrate the volume, which is pi r squared h again. Pi will stay. Once again, if we look at our radius, it's vertical. It's our y. So what's y? Well, x squared plus 4. So pi times x squared plus 4 squared times our h, which is just these lines here, which is going left to right horizontally, so dx. And from here, we rewrite and solve. I'm going to pull the pi out. X squared plus 4 squared will turn into x to the 4th plus, let's see, 4x squared plus 4x squared, which is 8x squared, plus 16 dx. Almost forgot my limits. Can't get very far without them. It goes from -1 to 2, again, because that's what we were told or asked to do. And so we'll end up with pi times x to the 5th over 5 plus 8x cubed over 3 plus 16x from -1 to 2. And I'll be perfectly honest with you. Could we do that as a fraction, as a bunch of fractions, and solve it? Sure. Do we want to? Not really. Let's use our calculator. With your calculator, you should get 78.6 pi. Definitely calc okay. If you want to do a bunch of fractions, go for it. One more example. Find the volume formed when y equals sine x from x equals 0 to x equals pi is revolved around the x axis. Let's draw a picture. So 0 to pi, let's say pi is there. The sine x curve, well, we know that sine of 0 is 0 and sine of pi is 0. So we'll do something like that. If we reflect it about the x-axis, get something like that. And now if we make our sample disk, here's our radius, here's the side of our disk, or coin, or whatever you want to think of it as. Think of those as actually, being relatively straight lines going horizontally. Now to set up our integral, we're going from 0 to pi r squared h. So 0 to pi is just pi. R in this case is the y value still in all these examples. So sine of x squared. And then our height, or really just kind of the thickness of our disk here, is once again dx. This is another one I really can't do. You should get 4.935. Also definitely with your calculator.